Hi, this is instruction on lesson 5.2, chapter 5, lesson 2 on proportions. I've got a bunch of vocabulary up here. I'm going to go over that and then erase it and then do some problems that will illustrate these principles. We learned in 5.1 that a ratio is a comparison of two numbers that don't have labels. Rate is a comparison of two numbers, but the numbers have different labels. So when you have a proportion, you have two ratios, and you could even say rates that are equal to each other. Like this would be an example, A over B equals C over D, so that's what we call a proportion. Then there are certain things that are true about A compared to B and C compared to D. If that is a true equation, the property of cross products says that you can multiply A times D, you're kind of going across here, that's where the cross comes from. A times D equals B times C. And actually, sometimes they draw little circles like this, or ovals, to group these terms together. And the numbers in the position of A and D are called the extremes, and B and C are called the means, which are sort of like the middle numbers if you relate to what we studied last chapter in statistics. Mean has something to do with the measure of center. These numbers in the middle, if you number these position 1, 2, 3, and 4, then 2 and 3 are in the middle, and A and D are on the outsides, or like the outliers or the extremes. So in some math classes you'll learn that the product of the means equals the product of the extremes, and that's mentioned in the text in this lesson in your book. So we'll do a few examples of that in a couple of minutes. The concept of proportionality just states that if you have a ratio of y to x, which actually does mean y divided by x, but writing it in a different way, y divided by x is going to result in a number. If you have a value for y and a numerical value for x, you can actually do the division. Sometimes you'll get a whole number, but often it's going to be a decimal number. Sometimes it's more than 1, sometimes it's less than 1, but it will be a number. And if you have a proportion, when you have this being true, y compared to x is the same as a compared to b, when you do y divided by x, you'll get the same number as if you do a divided by b. So we'll do some problems that shows how the numbers actually work when you use these properties. First of all, let's look at a proportion that you know is true. 4 compared to 8 will equal, this is a half, so I'm going to say it's a half. So if you use the cross products, this just demonstrates that it's true. 4 times 2 is 8, and 8 times 1 is 8. 4 times 2 equals 8 times 1. So both of those have a value of 8. So that's just an example. You can't really prove anything with one example, but it does demonstrate that it seems to work. If you have any three of these values, there's 4 numbers. If you know any 3 of them, you can figure out the missing one. So you can use cross products to figure out what the value of n is. You could use the equal fractions property, but that's kind of hard to do when there's not a whole number that you can multiply 4 by to get 6. If this was a convenient one like 2 to 3, 2 compared to 3 is 6 compared to number. This would be easy to do with the equal fractions property. What do you multiply 2 by to get 6? It's 3. So you do 3 times 3 to get the number that's missing here. So that does work, but it doesn't work so nicely here because, as I said, 4 times, not a whole number, it's actually 4 times 1.5, but that's kind of hard to figure out. So cross products works really nicely here. So you'd say 4 times n equals 6 times 6. And it's kind of nice to go ahead and do 6 times 6 is 36. Then it's a one-step equation, divide both sides by 4, and you get n equals 9, which seems to make sense. 4 compares to 6 the same way 6 compares to 9. So the missing number is a 9. There are some times, too, when it's convenient to just leave the product of the means, in this case, in factor form. Let me do some quick revision here to make this an 8. And don't even multiply it, just divide by 4, and you can reduce this because 4 goes into 4 one time and 4 goes into 8 twice, and n equals 12. So you didn't have to do 6 times 8 is 48, and 48 divided by 4 is 12. You just leave the product, express it as the product of these two numbers. It's often very convenient just to leave it that way, and then when you divide by this number here, you can sort of reduce your fraction before you multiply. Do another example that's not going to be, also not going to be, well, this one actually would be really obvious. 2 is to 5 and n is to 15. You can probably look at that, pause the video for a second if you need to, and figure out what n would be using the equal fractions property. And also try to do it with cross products, because you need to practice that. With equal fractions, you can see 5 times 3 gives you 15, and 2 times 3 would give you 6, so this is going to be a 6. If we, the n is in a different position, but that's not a problem. We can do either order we want to. We can do 5 times n if you like to have the variable on the left. You can just do that first. 2 times 15. Remember, I recommend, take a look at this. Don't just say 30 right off the bat, because you might like this better. Since 5 goes into 15 3 times, this would reduce, and n would be 6. If you did 2 times 15 is 30, it's not a hard problem. 2 times 15 is 30, and 5n equals 30, and 5 goes into 36 times. Okay, I want to talk about the constant of proportionality, and also introduce a ratio table. This is just showing that there's a ratio of 8 to 2. And that, if you have one, and then you have a bunch of others here, you can fill in all the missing numbers. I think I'll stop at those. So this is, what you're trying to do here is think about 8 compares to 2 the same way what number compares to 5. 8 compares to 2 the same way what number compares to 3. 8 compares to 2 like 12 compares to what number. And 8 compares to 2 the way 28 compares to what number. Now, I will add another one. If I had put 16 in here, it's pretty easy to figure out, because if you double 8, you get 16, so you'd think, well, I'm going to double 2 to get 4, and you'd be correct. Or if I do another one here and put, so let me multiply 3 by 2, put a 6 here. If you make 2 3 times larger, you get 6, so you would do 3 times 8 to get this number. But those relationships of whole number kind of things don't work so well here, because when you multiply 2 by to get 5, not so easy to see. But if you figure out the constant of proportionality, which would be 8 divided by 2 gives you 4. Now you figured out that the value of y is always 4 times the value of x. So you can figure out what's 4 times 5? 20. And then what's 3 4 times? Because 2 4 times is 8, 3 4 times would be 12. It works here. 4 times 4 is 16, 4 times 6 is 24. Then you have to reverse it here, because how do you go from 8 to 2? You divide by 4. So you have to do 12, oh, I got it up there. 12 divided by 4 is 3. Sorry about that. And here you would do 28 divided by 4, it would be 7. So that's how you can do ratio tables, using either the cross product idea, or looking for patterns, or using the constant of proportionality. Now I want to show you an application. I'm going to work through problem number 13 on page 109, which says how much would 10 bags of potato chips cost if 3 bags cost $6.25. There are various ways to do this problem. I mean, an obvious way would be to figure out the cost of 1 bag by dividing 3 into $6.25. Once you get the cost of 1 bag, you multiply it by 10. But develop your math skills and follow the directions, and you solve it using proportions. So we're going to solve this using proportions. We're going to say that you can spend $6.25 for 10 bags of chips. Then how much would it cost for 3 bags of chips? When you set up these proportions, it's important to put your labels in to make sure that you have the numbers in the correct position. Once I establish that this is going to be how I compare dollars to bags of chips, then I have to make sure that I do dollars to bags of chips in the other ratio. There's no reason I couldn't have done 10 bags of chips for $6.25. But now I have to make sure I put 3 bags as the first number, and then whatever letter I want to use. I'll get the same answer either way I do it, but you just have to be consistent to make sure that you match up positions. So here's your ratio, actually your rate, dollars to bags. It has to be dollars to bags. If it's bags to dollars on the left, it has to be bags to dollars on the right. So now I'm going to use some cross products and say 625 times 3 equals 10n. Then I'll do 625 times 3 would be 1825. You know what? You probably figured out that I made a mistake. Sometimes I just redo these videos when I make a mistake like this, but I'm going to let you just think about it for a minute. And I hope you already saw it. Something's not right. And then I'll go ahead and change. It's your think time. It doesn't really say that 10 bags cost $6.25. It says that if you spend $6.25, you get 3 bags. And the question is, how much would 10 bags cost? So I'm going to redo and say 625 times 10 would equal 3 times n. That's looking better. Okay, this will just move the decimal over one place and be 6250 and 3n. And I'm kind of curious to know, am I going to get a remainder here when I divide by 3? Because 6 and 2 makes 8, and 5 more makes 13, and 3 doesn't go to 13. So I can expect that I'm going to have a remainder when I do this division. But I will divide both sides by 3. And then the arithmetic is to do 3 into 6250, 2 times, remainder 0. 3 doesn't go into 2 evenly. That also is 0. Then 25, 3 goes into 25 8 times, remainder 1. 3 goes into 10, 3 times, remainder 1. I'm just going to keep getting 3's. So this would be dollars, $20.83 to the nearest dollar. So 10 bags of chips would cost $20.83. And that's the kind of problem that you'll be able to solve when you use proportions and cross products.